So guys, today we're going to discuss about in physics chapter number 13 it is. Okay, so that is magnetic effects of electric current. So electricity, we have an idea. Now it is magnetic effect of electric current. Okay, so yeah, again coming to this, the magnetic effects, a very easy chapter. Almost everything we know. Okay, almost everything we know. So maybe in the lower classes, okay, maybe in the lower classes we have studied about the iron, correct? Or else we already know iron will obviously get attracted to what? Magnet, correct? Yes, iron piece will be getting attracted to a magnet. Or else I can say that magnet is any substance that attract iron. Iron get attracted to what? Magnet. Or else I can say what is one more thing? Magnet is any substance that get attracted to iron. So in any manner I can say. So always remember these things. So again, I am not teaching you a definition of magnet. I am actually, what I'm trying to convey is how do you connect things again. Okay, so I want you to stop studying in a conventional manner. Okay, definition of magnet is any substance that get attracted to it. That's not the way to do it. Think of a real-time example. Okay, we already know iron filings are, when we bring the coin or anything close to a magnet, it get attracted, correct? So magnet is any substance that get attracted to iron. Yes, correct. Yeah. Now, but the chapter here is magnetic effects of electric current. Okay. Now I'm just going to remove my mic. Let me switch on the video now. So guys, how many of you have got electric kettle in your home? Electric kettle. Electric kettle is available or not? Let me know. Okay. So those who have got it, okay. Chinmay, can you just unmute your video, not audio? If possible, make sure that video is also on. Okay, that anyway, I'll tell you about the video thing in the later part of the session. So Chinmay, could you please unmute, or is there any disturbance? What I wanted to ask you is, have you, for example, electric kettle is there? I think obviously you might have used it. So when it is so hot, did you ever feel some magnetic? Okay, did you ever feel some if you're going to touch it, some kind of shock or something like that? Have you ever felt it actually? Not shock, I can tell you, some kind of presence, some kind of wave like thing. Have you ever felt? Yes. Fine. So since your mic is not working, I just saw from your chat, it is yes, sir. So those who got electric kettle at home, okay, even I got an electric kettle. So coming to that, what I want to tell you is that whenever we heat it, okay, and we will just go and touch, okay, whether there is hotness in the kettle or not. Sometimes we will find that kind of what we will, some external presence will be there. Not a shock, I can tell you, but some kind of presence is there. In the sense, some wave or something is touching us. Okay, so you would have felt it. Okay, so electric kettle is one example. Okay, which I see in my real time. Okay, since I am in my room, I can see my electric kettle. So again, studying is all about what relating things which is around you. Okay, so that we need not study it again and again. So what I wanted to tell you is I want you to everyone to come back to this topic. What is our topic? Magnetic effect of electric current. Okay, in the sense kettle, it is an electric kettle I'm discussing about. I'm discussing about what? Electric kettle. Correct? Electric kettle needs electric current to pass. Yes. So that wave-like thing, that is nothing but the magnetism, or that is a magnetic field. Okay. The shock or something, no, which is telling us, okay, which we can feel it. Okay, that is nothing but what magnetic field waves or magnetic waves. So that is nothing but our magnetic effect. In the sense, all the current carrying object will have magnetic field. Okay, let me just write it down here. Very important for you to know this one. All the electric current, or else let us take all the electric current carrying objects, or else in simpler way I can write here electric current. What, for example, it behaves like a magnet. Also, all the electric current carrying here, how is electric current carried? Through the magnetic kettle wire, right? To the kettle wire. Kettle wire. Yes, it behaves like a magnet. All the electric current carrying, I need not write the kettle wire here, but for you to understand only, I'm just putting it down. Okay, if you want, you can just delete this thing off. What I want you to remember is the wire, right? That carries the current. Anything which carries the current behaves like a magnet. Write down here. Anything which carries the electric current, which carries electric current, behaves like a magnet. Is it clear to everyone? So those are not two different terms. Which one? What I want to tell you is that electric current and magnet both are not different terms. They are actually the same. Up to this, is everyone clear? Perfect. Yeah, very good. Okay, the boys also can chat. Yeah, good, Rohit. Because I want everyone to be in the same page. Okay, fine. A very important topic. Again, guys, just remember only one thing, that I don't want you to study it again and again. Okay, fine. That's the reason I am teaching it slowly so that everyone will understand this. So this is our first topic in this. Now, let me take I think everyone knows this thing. Uh, like pairs repel, opposite pairs attract. Does everyone knows this? I removed my mic now. Okay, for a magnet, if I wanted to speak, properties of a magnet. Let me write here. Properties of a magnet. So first property, we all know what it is. It will have two poles, north and south. Correct. And one more important thing is, like pair repel each other. Repel. Opposite pair attract each other. Yeah. How many of you know these things? Magnet has got two poles, north and south. How many of you know it? Good. What about the second point? Yeah, very good. Second point, like pairs repel each other and opposite pairs attract each other. So Aditi, could you please tell me what is the example for this opposite pair attract each other, like pair repel? Where have you seen this? Like pair repel. You can unmute and speak. You can unmute and
Magnet, sir.
magnet. In the sense how it is, can you just explain a little bit on that? Like pair in the sense what it is. If I keep a north pole and north pole, will it get attracted?
No, sir. Like it will repel. Like
Ve-
pairs will repel, and opposite pairs will attract.
Attract. Very good.
Yes.
So obviously that is our magnetic property, right? Correct? Yes. So that is nothing but our properties of a magnet. I think everyone knows this. I think in the lower classes you might have studied this. 8th standard, or I'm not sure when it is. But I think in the lower class have you studied about this? In physics only? Like pair repel and opposite pair attract each other. Hmm? Good. Okay, perfect. So I think everyone knows these 2 points. Correct? Now let me go to the next point then. So these are the 3 points, the first 3 points. The next point. So what is our next point here? I'll write it down. Anyone who doesn't know, let me know. A freely suspended bar magnet. Okay, if I suspend a magnet, bar magnet in the sense, I'll just draw it. Maybe since it is, okay, let me go to the next page. Let me, this is looking like a chocolate bar, right? Correct. This is a magnet. Obviously, it's a, we are assuming that this is a magnet here. Okay, so this is a magnet, correct? So if I freely suspend it, if I freely suspend this magnet, correct? They are telling that we all know what is it. Everyone knows this thing. This north, correct? South, then west and east, W and E. So this will align as what? North pole and south. In the sense, if I simply hang a bar magnet, it will assign to itself. Okay, north pole, it will act. Yes. So this north pole of the magnet will be in north direction. South pole of the magnet will be in south direction. Clear or not? A magnet has got 2 poles. One is the north pole and south pole. If I just hang this magnet freely, that is suspending this magnet freely, the north pole of a magnet will behave as what? North. South pole of a magnet will behave as south. Is it clear? Is it clear to everyone? So now can we write down our own words? So how will we write this thing? Correct? If freely suspended, correct? Freely suspended, freely suspended. Suspended is again a difficult, but again suspension. Correct? Freely suspended bar magnet. Bar magnet aligns itself. Correct? In what? North south direction, where its north pole is towards what? Is towards north direction. North direction. You can write it in your own words. Okay, you can write even like this: when magnet is suspended, when a magnet is suspended, yes, a bar magnet will have what? Two poles, north pole and south pole, correct? The north pole of the magnet aligns itself in north direction or point towards the north direction, and south pole of the magnet will point towards the south direction. That's it. So again, we are learning. There are four ways of learning the things also. What is it? Numbers, words, variables, and diagrams. So if I am learning through what? The diagrammatic view, which is what? Our this one. This is my diagrammatic view, correct? So I'll be able to learn much better. So that is the only reason why I am giving you in different color pencils. Okay. Okay. So if I'm putting this much effort, at least 80 to 90% of the effort should go to your head. So that I want to make sure that everyone understand this and you'll be able to think and write it down. Clear, everyone? So magnetic field lines, correct? So that's what we have been discussing now. We all know how does the magnetic field lines will look. So that I'm going to discuss now. Okay, very easy topic for us to remember. Again, I'll draw it through diagram only. Magnetic field lines. That's the best way to remember things. So I'm going to draw. Let me switch on my video. So I'm going to draw two circular shape I drew, right? Now, yeah. So this black kind of things, correct? The circular thing, black kind of thing is there, no? This is nothing but the black spots, as you can see. These black spots are nothing but my magnetic field lines. These are nothing but my magnetic field lines, first thing. Okay, first thing is that only. These are nothing but my magnetic field lines. What can you observe from this? In the first case, in the case number one, the magnetic field lines, are they very close to each other? My question is, are they to each other? Are they very close to each other? Or else which one is more closer? Number one or number two? You can tell me. Yes, clearly we can see what? From number one, the magnetic field lines are closer, in the sense when the magnetic field lines are closer, it shows strong magnet properties. Strong magnet. So other one will be weak magnet. Again, we have to what? Go through diagrams. Okay, to learn. So if you ask me, sir, what is this things? For example, in one thing I drawn like this, the black color thing, right? I drawn something like this, circle thing. So each line has got what? North and south pole. This is north, this is south. So this will be what? This will be south, this will be north. and so on. If I want to write here, what I will write here? This will be north pole of this. This is south pole of this. Then this is north pole of this, south pole. Here again, north, south, north, what? South, north. Is it clear to everyone? Is this thing clear? This is the thing which I want you to visualize. Okay, so end of the day is a very simple topic. Okay, where we have to study. Is it clear to everyone? This one. So the magnetic field lines, okay, which are closer to each other will have or will behave as a strong magnet. Is it clear to all or any doubt? Is it clear to all or any doubt is that? Very good. Yeah, I think everyone can see the screen now. Yeah, so coming to this particular page here. Can you see that? This page. We can see this guy's hand, right? What is this blue color thing? This blue color thing is nothing but what? The wire. The wire. And in our hand, what is passing through the wire? If I switch on the what do you tell, the switch, electric current, if there is a power supply, electric current will be passing through this wire. Everyone agree with that? Electric current passes through the wire. Yes. And my finger wrapped, the finger, we can see this is wrapped, right? Correct. The fingers are wrapped, right? Yes. Yes or no? Yes. So this is my magnetic field lights. That is the same thing in the electric kettle. In the electric kettle, what we are getting? In the electric kettle, we are getting some shock or something, right? Or we can feel some waves, no? Correct. That is nothing but because of the current carrying wire. We can feel it. So what is my thumb indicates? My thumb indicates the direction of electric current. I'll write down here. The thumb indicates direction of current. Direction of current. And my other finger indicates what? The presence of magnetic field lines. This is nothing but an electric kettle example, which we discussed in the beginning. We can feel the wave. Okay, we can feel something. You got the point? Huh? So if we again try to connect with the real time example, we can learn right hand thumb rule easily. So what is this right hand thumb rule? We are holding a what? We are holding a wire, current carrying wire. Our thumb indicates the direction of current. Yes. And other finger, yes, indicates the direction of magnetic field lines. Is it clear to everyone? I'll write down now in words. Right hand thumb rule. Okay, again, kindly visualize the picture. Okay, right hand thumb rule. What is the right hand thumb rule statement in this? Yes, if I hold a current carrying wire, if I hold a current carrying wire, current carrying wire, my thumb indicates the direction of current. My thumb indicates direction of current, and my other finger wrapping around the wire describe the magnetic field lines. Example, what I told you in this example was the electric kettle example itself, where if I'm going to touch the kettle, the kettle switch is on, yes, and if I'm going to touch it, sometimes I can feel that wave, external wave I can feel. Clear? So again, with the diagram only, I'm trying to teach you everything. Is this thing clear to everyone? My question is, from laptop or any electric thing, has anyone got a shock till now? A shock kind of thing, or some other external so again, no, not shock, I can tell, maybe a kind of yeah, the vibration or something. So again, that is nothing but a magnetic field presence. You got the point. I think Aditi has got it, Rohit has got it. Okay, so I don't want anyone to get that shock. I'm just telling you to feel that wave. Okay, I don't want personally to anyone get shocked from those things. You got the point. But it shows that electric current, we know without the passage of electric current, we can't get any of our electronic devices get worked. Correct? So this is the nature of what, or nature or the presence of electric field. Again, if I want to come in the beginning, I want to tell you what magnetic effects of electric current. So that shock is nothing but what, our magnetic effect. Again, I am coming back to my this only, the chapter, magnetic effects of electric current, this particular thing. Clear? Yeah. So we can all see this particular one. Let me just I just saw this particular screen, this diagram here, the yellow color one which I have marked. Correct? Now one thing what I want to specify and mark here is, this is my magnetic field and this is my current. Are they perpendicular to each other? This is my Fleming's left hand rule. Okay, my question here is, in this diagram, the diagram which you can see, are they perpendicular to each other, the magnetic field and current? So in Fleming's left hand rule, the magnetic field and the current are what? Perpendicular to each other. You got the point. The magnetic field and the current are perpendicular to each other. So again, through what? Through diagram only we are able to learn. Is it clear? The magnetic field and current are perpendicular to each other. In which one? In Fleming's left hand rule. But then there is something called our thumb. Yes, my forefinger shows what? My forefinger shows magnetic field, middle finger shows the direction of the current, and my thumb, there is something called motion written, or it is a force. Yes, correct. And my thumb shows the direction of motion of that. For example, the wire is there. Yes, current carrying wire is there. Where is the direction of the wire going? That's the thing. Okay,
What is the effect of current to that particular object? That only my thumb shows. But the important point in Fleming's left hand rule, very important point is what? I'll write down here. Fleming's left hand rule. Most important thing in this is current and magnetic field. Current and magnetic field are perpendicular to each other. Okay. Then what is the other thing? What is the other point in this? Very important thing for you to remember. Forefinger. Forefinger is what? Current. Yes. Middle finger. Yes. Anything. Or else if you want forefinger, you can put magnetic field, or middle finger you want current. Anything. Okay. Middle finger, anything. This can be either current or magnetic field. Current or magnetic field. Okay. So we need not by heart, again I'm telling. We need not by heart. Middle finger again what? Current or magnetic field. Only condition for us is what? In some textbook they'll say that forefinger is what? Magnetic field. Middle finger is current. In some other textbook they'll say that what? Forefinger is current and middle finger is magnetic field. So it can be either of the same. But thumb is what? Thumb is nothing but force or direction of motion. Force or motion of the object. Is it clear to everyone? So what is my Fleming's left hand rule? Correct. If my forefinger shows the direction of current, middle finger shows the direction of magnetic field. Okay, then the thumb shows the direction of motion of the object or the force applied on the object. Is it clear to everyone? If you are using here current, you would use here magnetic field. If you are using magnetic field here, you would use current, or vice versa. Is it clear to everyone? So this is my important in this. And one more thing is current and magnetic field are perpendicular to each other. Current and magnetic field are perpendicular to each other. Clear up to this to everyone? Yeah.
Has everyone heard about MRI scanning? MRI scanning. Heard about it? Yes. Now coming to the MRI scanning here. What is this MRI scanning meaning actually? MRI or magnetic resonance, and ultimately what I'm getting, I is for what? Image. I is for image. Now we will discuss about that now. MRI scan. Okay, what is application of that also? So coming to my magnetic resonance imaging or MRI, what I am getting from this, with the help of magnetic field, I can see what? I can see the internal organs of the body. Clear? So, which means our brain, correct? Our brain and heart. Yes, our brain and heart has got significant, our brain and heart has got what? Has significant magnetic fields. Clear? So that with the help of this scan, magnetic resonance imaging or MRI scan, we can get a detailed view of our internal organs, because our brain and our heart produces magnetic field. Is it clear to everyone? So these are the application of what? Fleming's left hand rule. The MRI scan is nothing but the application of Fleming's left hand rule. MRI scan to get, for example, in this particular here, we can see what? We can see our internal organs. Okay, magnetic resonance imaging, in the sense, image of our internal organs can be obtained by using what? MRI. Okay, so what I'm trying to tell you is that our heart and brain, our heart as well as brain has got what? Magnetic field lines. In the sense, we also produce some kind of what? Magnetic field. For example, let's take anything. Now we are communicating through the internet, right? Correct. We have a Wi-Fi at home. Yes. What is this Wi-Fi basically? Electromagnetic waves. Electromagnetic waves in the sense both electric and magnetic fields. Clear. So detail down the line, maybe in your higher classes, you will learn in detail about it. Okay. So every object, okay, every object, or almost, let's take around 80% of the object, okay, possess this magnetic field property. MRI scan is nothing but with the help of MRI scan, I can see the internal organs of the human body clearly, especially our brain. MRI is for what? Scanning your brain, right? Our brain has, or it sends magnetic signals because it has got our magnetic field lines. Okay, so by using the scan, we can get a proper image of our brain respectively. That's all. That is my MRI scan, mainly for the head as well as the whole body. Also, they'll do.